In this video, we'll talk about rational exponents. Here we have 15 raised to a rational exponent, 15 to the 1/3 power. We're asked to write it as a radical. The 1/3 power is the same thing as saying cube root. So the first expression is the cube root of 15. In the next expression, we have the 4th root of 2n cubed, which we should raise both the 2 to the 3rd power and the n to the 3rd power. So this is the 4th root of 8n cubed. So in the next example, we'll give you radical notation, and we're asked to write using exponential. So radical, the square root is the 1/2 power. So this will be 4 times xy to the 1/2 power. So this is 4 x to the 1/2, y to the 1/2. We typically don't leave parentheses in our answer, which is why I rewrote it as that final answer. In the next one, we have the 7th root, which is raising something to the 1/7 power. And again, when we raise a power to a power, we multiply our exponents. And my final answer is x to the 3/7, y to the 3/7. X to the 3/7, y to the 4/7. Now we're asked to simplify some radical expressions. And what we want to think about is how can we rewrite 45 so it's a perfect square times something else? Because 45 is not a perfect square, but 9 times 5 is another equivalent form, and 9 is the perfect square. So when I take the square root of 9, I get 3. Now we'll just multiply those two numbers in front of the radical. We get 6 radical 5. That's called simplest form of the given radical expression. In the next radical expression, we want to start thinking about perfect cubes. So 125 is already a perfect cube, but x to the 8th is not. X to the 6th times x squared would work, because now x to the 6th is a perfect cube. Now we can take the cube root of 125, and that's 5. The cube root of x to the 6th is x squared. The cube root of y to the 6th is y squared. And what's left inside the radical, the cube root of x squared. So that is now in simplest form. More practice simplifying radical expressions. Let's rewrite 20 as 4 times 5. And let's rewrite x cubed as x squared times x. Now let's take the square root of 4 and the square root of x squared out of the radicals. Square root of 4 being 2. Square root of x squared is x. Multiply that by what's already there, the negative x. And now just simplify your answer to negative 2x squared, square root of 5x. The next example, we have cube root. So we want to think about rewriting 54 as some perfect cube times something else. So 27 times 2 would work. Let's take the cube root of 27, and that'll be 3. We'll take the cube root of c to the 3rd power, and that'll be c. What's left over is the cube root of 2. Right, next we have a product of radicals, and to simplify this, we want to kind of put it all together. And this will be, instead of even multiplying 3 times 3 to get 9, we can notice right here that I can take the square root of 3 times 3, it'll just be 3. I can take the square root of x times x, it'll be x. And what's left inside the radical will be 7x. So that's my final answer on that one. Now this next example, you're not allowed to have a square root in the denominator. So we rationalize the denominator by multiplying by the conjugate of the denominator. So we're going to multiply by a disguised form of the number 1. 3 plus root 2 over 3 plus root 2. So our numerator is going to be 3 plus root 2. Our denominator now, we're just going to apply the difference of perfect squares, will be 9 minus 2. We simplify this answer to be 3 plus root 2 all over 7. That answer is better because now there is not a square root in the denominator. Next example, we're asked to simplify a radical expression where there's a product of two binomials. In essence, we can use FOIL. We also could have used the box strategy or double distributive. I'll use FOIL. So F stands for the first two. So when we multiply these first two terms together, we get 2 times 3, or 6. Now the outside 2, it's going to be simply the square root of 3 times 4, which we typically rewrite as 4 root 3. The inside 2 will be negative 2 root 3. And the last two terms multiplied together will be negative 4. Now what we do is we add these partial products and we get 6 minus 4, thinking of like terms, plus 4 root 3 minus 2 root 3. We'll combine our like terms here and we get 2 plus 2 root 3. Okay, the next example we can see there's a square root in the denominator, which is not allowed. So to rationalize this, we're going to multiply by a disguised form of the number 1. We'll multiply by square root of 6a over square root of 6a. My numerator is 4 root 6a. My denominator is 6a. And I can simplify this fraction by dividing the 4 in the numerator and the 6 in the denominator by 2. So this becomes 2 root 6a over 3a. Now we're going to be evaluating some expressions, typically, most likely without a calculator, so you need to be aware of how to do this. What we don't want to do is raise 9 to the third power and take the square root of that. That's a lot of work. Instead, let's start with this denominator of our rational expression. So this denominator means I'm taking the square root of 9. And whatever that is, I'm going to raise it to the third power. So the square root of 9 is 3. Raised to the third power will give me 27. In the next example, 9/4 to the negative 1/2. First, let's deal with the negative 1/2 by writing the reciprocal of the fraction. Now recognize the 1/2 power is the same thing as square root. So we'll take the square root of the numerator and the square root of the denominator. In this last example, because we have a negative exponent, to make that positive, we're going to flip the fraction and we get 125 to the 2/3. Now we're going to do the cube root of 125, which we know is 5, and then we'll square that. So again, 5 squared gives us 25. Okay, in the last slide here, we're going to be dealing with some rules of exponents to refresh your memory. Remember in the first example, when you have like bases and you're multiplying them, you add your exponents. So this one is a to the 5/7. It did not say to write it in radical form, so it's okay to leave it with this rational exponent. In the next example, because of the negative power, let's flip the fraction to make it a positive 1/2. Remember, 1/2 just means square root. So the square root of your numerator is going to be 7y. The square root of your denominator is going to be 6x squared.